Chapter 6 Network Layer. In the network layer, there's the addressing and devices, encapsulation, routing, and encapsulation. First, the addressing and end devices. End devices must be configured with a unique IP address for identification on the network. Encapsulation. The network layer encapsulates the protocol data unit or PDU from transport layer into a packet. The encapsulation process adds IP header information such as IP address of the source, sending, and destinations, receiving host. Routing. The network layer provides services to direct packets to a destination. Host on another network. To travel to other network, the packet must be processed by a router. The role of the router is to select the best path and direct packets towards the destination host in a process known as routing. A packet may cross many intermediary devices before reaching the destination host. The encapsulation. When the packet arrives at the network layer of the destination host, the host checks the IP header of the packet. If the destination IP address within the header matches its own IP address, the IP header is removed from the packet. After the packet is decapsulated by a network layer, the resulting layer for PDU is passed up to appropriate service at the transport layer. Characteristic of IP protocols. IP was designed as a protocol with flow overhead. Provides only the functions that are necessary to deliver a packet from a source to a destination over an interconnected system of network. The protocol was not designed to track and manage the flow of packets. These functions, if required, are performed by other protocols at other layers, primarily TCP at layer 4. The basic characteristic of IP are described the following. First, the connectionless. The connectionless, no connection with the destination is established before sending data packets. Second is best efforts. IP is inherently unreliable because packet delivery is not guaranteed. Third is the media independent. Operation is independent of the medium, i.e. copper, fiber optic, or wireless carrying data. IPv4 packet header. An IPv4 packet header consists of fields containing important information about packet. These fields contain binary numbers which are examined by the layer 3 process. The binary values each fields identify various settings of the IP packet. Protocol header diagrams, which are read left to right and top down, provide a visual to refer to when discussing protocol fields. The IP protocol header diagram in the figure identifies the fields of an IPv4. Significant fields in the IPv4 includes version, and the version contains 4-bit binary value set to a 0-100 that identify this as an IP version for packet. Differentiate service or diffserv DS, formerly called the type of service TOS field, that the DS field is an 8-bit field used to determine the priority of each packet. The 6 most significant bits of the diffserv field is the differentiate service code point, DSCP, and the last 2 bits are the explicit congestion notification ECN bits. Time to live TTL contains an 8-bit binary value issues limit lifetime of a packet. The packet sender sends the initial TTL value and its decreased by 1 each time. The packet is processed by a router. If the TTL field decrements 0, the router discards the packet, send an Internet Control Message Protocol or ICMP time exceed message to the source IP address. Protocol fields used identify the next level protocol. This 8-bit binary value indicates the data payload type that packet is carrying, which enable the network layer to pass data to the appropriate app layer protocol. Source IP4 address contains 32-bit binary value that represents the destination IPv4 address of the packet. The destination IPv4 address is an unicast, multicast, and broadcast address. Limitations of IPv4. Through the years, IPv4 has been updated to address new challenges. However, within changes, IPv4 still has 3 major issues. IP address depletion. IPv4 has limited number of unique public and IPv4 addresses available. Internet routing table expansion. A routing tables is used by routers to make best path determination as a number of servers connected to the Internet to increase thus the number of network routes. Lack of end-to-end connectivity. Network address translation or NAT is a technology commonly implemented within IPv4 networks that provide a way for multiple devices to share a single public IPv4 address. However, because the public IPv4 address is shared, the IPv4 address of an internal network host is hidden. Introducing IPv6. In the early 1990s, the Internet Engineering Task Force (IETF) grew concerned about the issues with the IPv4 and began to look for a replacement. Improvement that IPv4 provides include increased address space. IPv6 addresses are based on 128-bit hierarchical addressing opposed to IPv4 with 32 bits. Improved packet handling. The IPv6 header has been simplified with fewer fields, eliminates the need for NAT. With such a large number of public IPv6 addresses, NAT between a private IPv4 address and a IPv4 is not needed. IPv6 packet header. The fields in the IPv6 packet header include version. This field contains 4-bit binary values to set 0110 that identifies this is an IP version packet. Traffic class. This 8-bit field is equivalent to the IPv4 differentiated services DNS field. Flow level. This 20-bit field suggests that all packets with the same flow level receive the same type of handling routers. Payload length. This 16-bit field indicates that the length of data portion or payload of the IPv6 packet. Next header. This 8-bit field is equivalent to IPv4 protocol field. It indicates the data payload type that the packet carrying, enabling the network layer to pass the data to appropriate layer protocol. Hop limit. This 8-bit replacement to IPv4 TTL field. Source IPv6 address. This 128-bit field identifies the IPv6 address of sending host. Destination IPv6. This 128-bit field identifies the IPv6 address of the receiving host. Host forwarding decision. Another role of network layer is to direct packets between hosts. A host can send a packet to itself, localhost, and remote host. In itself, a host can ping itself by sending packet to a special IPv4 address of 127.0.1. Localhost. This is a host on the same local network as the sending host. The hosts shared same network address. Remote host. This is a host on a remote network. The hosts do not share the same network address. Host routing tables. Entering the next start are commanding, or the equivalent route print command displays three sections related to the current TCP or network connection. There's the interface list, IPv4 route table, and IPv6 route table. So that's all the summary that I create in the chapter 6. So we finished the summary of the chapter 6 titled Network Layer. So for now, we will answer some activities from the chapter 6. So we go. Activity part 1, IPv4 header fields, which, so I'm gonna talk the answer and go with the box. Proceed to another activity. Same as direction in the previous activity. I get again all the correct answer, I will proceed to another activity. Same as the previous activity. So I get all the correct answer again. So that's now for all activities in the chapter 6. Please do not forget to subscribe my channel.